So, have you ever really stopped to wonder what the world around you is made of? I mean, everything. From the device you're watching this on to the chair you might be sitting in, it's all built from different materials, and every single one has its own secrets. Let's get into it and uncover the huge differences that honestly shape our entire world.
Our story starts, believe it or not, in the workshop of an ironsmith named Sudarshan. Picture this. He's heating a block of iron till it's glowing red hot, and then, bam, he's hammering it into shape. It's this really powerful, ancient process, and just watching this simple act, well, it sparks a really important question.
And there it is. A young girl, Anandi, sees the iron bending and changing shape, and she wonders, can you do that with everything? Her simple but totally brilliant question, that's our launchpad for figuring out what really makes one material different from another.
Okay, so let's follow Anandi's curiosity here and start with the most basic thing you can do. What happens when you hit something with a hammer? You know, when you apply force.
This brings us to our very first scientific test. We're going to explore a property, and it's a cool word, called malleability.
Right, so here's the official definition. Malleability isn't just about something changing shape. It's the ability to be hammered into super thin sheets without shattering into a million pieces. That last part, without breaking, is absolutely the crucial point here.
This table just lays it out perfectly. You take an iron nail and hammer it. What happens? It flattens. It's malleable. But try that with a piece of coal. It just shatters. It's what we call brittle. See? The exact same force, but two totally different results.
And think about where you see this in your own life. Ever seen that super thin, shiny silver foil they put on fancy sweets? Or, I mean, everyone's used aluminum foil, right? That is malleability in action. In fact, gold and silver are the most malleable metals on the planet.
So, malleability, that's just one piece of the puzzle. Let's broaden our view a bit and look at some other physical properties. And as you're about to see, there are some pretty fascinating exceptions to the rules.
Okay, so here's the general rule of thumb. Metals, they tend to be lustrous. That's just a fancy word for shiny. They have that special metallic shine when light hits them. They're also fantastic conductors of heat and electricity. Non-metals, on the other hand, are usually pretty dull-looking and are really bad conductors, which, by the way, is why we use them as insulators.
Seems pretty straightforward, doesn't it? Metals are shiny, hard, and they conduct stuff. But is that always true? You know, science just loves to keep us on our toes.
And here are the curveballs. Get this, the metal sodium is actually so soft you can cut it with a regular kitchen knife. No way. And then you've got mercury, which is a metal that's a liquid at room temperature. You know, like in the old thermometers. These exceptions are what make this whole thing so cool.
All right, we've looked at their physical side. Now let's switch gears and explore how these materials act chemically. You know, what happens when you just leave them out in the open, exposed to air and water and all that stuff?
Let's start with something we've all seen, rust. You can actually think of it like a simple three-step recipe. Step 1, start with some iron. Step 2, add some air, specifically the oxygen in the air. And step 3, add a little water. Mix them all together, and voila, you get iron oxide, that reddish-brown, flaky stuff we call rust. Now, rusting is really just one example of a much bigger process called corrosion. It's the slow, gradual destruction of a metal because of how it reacts with its environment. You've probably seen it before, like that green layer that forms on old copper, or the way silver gets that black tarnish. It's just the metal reacting with the world around it.
Okay, look at this number, 1600. Just 1600. What on earth could that mean? Well, it's the key to one of the most incredible stories in the entire world of metals.
That number, that's the age of the amazing Iron Pillar of Delhi. For over 1,600 years, this thing has been standing outside, getting rained on, baked by the sun, and it has almost no rust. How is that possible? Scientists think it's because of a super thin protective layer that formed on its surface. It's an absolutely stunning testament to the skill of ancient Indian metallurgists.
So that incredible pillar brings up a great question. What even is iron, really? To answer that, we have to zoom way, way in and look at the fundamental building blocks of, well, everything. You see, at their very core, both metals and nonmetals are just different types of elements. And an element is a pure substance that you just can't break down into anything simpler. There are 118 of them that we know of, and they are the basic ingredients that make up the entire universe.
Okay, so let's wrap this up. Here are the key differences in a nutshell. Physically, metals are shiny, malleable, and great conductors. Nonmetals, they're the opposite, dull, brittle, and poor conductors. But chemically, here's another huge difference. When they react with oxygen, they make something called oxides. And here's the really neat part. Metal oxides are usually basic, which is the chemical opposite of acidic. Nonmetals, you guessed it, form acidic oxides. They're on opposite ends of the scale.
And that brings us to one last thing to think about. Now that you know all this, just look around you, right now. Why are the wires in your walls made of copper, a metal, but coated in plastic, a nonmetal? Why are your pots and pans metal, but the handles are often made of wood or plastic? The answers are all right there, in the properties we just talked about. It's everywhere you look.